Okay, guys, on this midterm bell ringer, we are going over exponents. So let's practice evaluating. And we're going to do this without a calculator. So 3 to the 4th means that we have the number 3 being multiplied by itself 4 times. So 3 is the base and 4 is my exponent. So we're going to write out 3 times 3 times 3. And what I like to do is, especially when I have an even amount of factors, I like to multiply them in pairs. So 3 times 3 is 9 times 3 times 3 is 9. And then I get 81. So 3 to the 4th is 81. Again, my base was 3 and my exponent was 4. In number 2, we have negative 3 to the 4th. In this problem, the base is 3 and the exponent is 4, and we have this understood negative 1 attached out front. So I have negative, and then I have 4 3's being multiplied. The negative, whoops, I about wrote the negative. The negative is not part of the base. It is not expanded. So we have negative, and then we have 4 3's being multiplied. So we're going to have 3 times 3 is 9. I'm going to bring down my negative. I have another 3 times 3, which is 9. And when I multiply this, I get negative 81. Now let's look at number 3. I have negative 3 raised to the power of 4. So my base this time is negative 3. Negative is part of the base, so we expand the negative on number 3. I'm going to multiply my pairs together. I get a negative times a negative is a positive, so I get positive 9. Negative 3 times negative 3 is positive 9. And when I multiply 9 times 9, I get 81. So make sure you know the difference when to expand the negative and when to not. So again, negative 2, I read it as negative 3 to the 4th. Number 3, I read negative 3 to the 4th. Okay, now let's write expressions as an exponent. So we have negative a times a times a. So I have a negative, and then I have a to the 3rd, and then I have b times b times b. So I have b to the 3rd. That is one way that you could write this expression. But because we have commutative property, I could have negative and then in parentheses ab raised to the power of 3. But the negative is not included as the base because I'm not expanding the negative. So we can say negative and then put AB in parentheses raised to the 3rd power. So these are both acceptable. Number 5, when we do a fraction, we definitely need parentheses. So we have our negative, but it's not part of the base because it's not expanded. And then I have 1/2, which we have to put in parentheses to make sure that we have the numerator as part of the base as well as the denominator. So we have negative 1/2 to the 4th. Okay, now let's practice our power rules. So remember when you are multiplying like factors such as n and n, when you multiply, the rule is the product rule. We're going to add exponents. So let's call this the product rule. So that's when we're multiplying two factors, we add the exponents to simplify it. So let's just start there. So number 6, we have two factors that are the same. So we have 1 and 2 factors, and we can simplify by writing it as one factor. So we have n to the 5th, because n to the 3rd, is n times n times n times 2 more n's. So let's fix this up just a bit. Make it so we can see what really is going on here. So n to the 3rd is n times n times n, and then I had 2 more n's. So we had 1, 2, 3, 4, 5 n's. Okay, number 7, we have w to the negative 2nd times w to the 4th, Instead of having two separate factors, we can write this as a single factor of w, and then the rule says to add exponents. So negative 2 plus 4 is 2. Number 8, we have the factors of k, and we are multiplying these two factors. So the rule says to add exponents. Negative 3 plus negative 1 is negative 4. And remember, we can't leave a negative exponent, so we're going to reciprocate and move our factor of k to the denominator, making us have a positive exponent of 4. Now, the next 3 is we're going to use the division, or I should say we're going to be dividing. All of these are dividing, so we use the quotient rule. So quotient means to divide, and that rule says to subtract exponents, top minus the bottom. So I have two factors of n, and it's dividing, so we write down our factor, and the rule says to subtract exponents. 6 minus 2 is 4. Because really what is going on here, if I expand into the 6 and I expand into the second, we know that anything over itself cancels, and this leaves me with 1, 2, 3, 4 n's being multiplied. Okay, number 10, we're going to use the quotient rule because we have division going on, and the quotient rule says to subtract. So my factor is w, so you just write that down. And then I'm going to say 5 minus negative 1. 5 minus negative 1 is the same as 5 plus positive 1. Keep, change, change. 5 plus 1 is 6. Oh, number 11, our factor is k. We have division going on. We're going to use the quotient rule, which says subtract exponents. So negative 2 minus 6. Again, I'm going to say keep, change, change. I get negative 8. We have to simplify the negative on the exponent. So this is equal to 1 over k to the positive 8. And then we have our power to a power. So I'm just going to say power to a power rule. And that says we are going to multiply exponents. So every factor has an exponent. So this is n to the second raised to the third. So this is like we have n squared times n squared times n squared. That's where the 3 comes. Then if I expand n times n and another n times n and a third n times n, we really have 1, 2, 3, 4, 5, 6 n's being multiplied, and that's why we multiply power to a power and we get n to the 6. Here our factor is w, and we multiply. We have a power to a power. We multiply and get negative 5. We can't leave a negative exponent, so we reciprocate, meaning take it down to the opposite location. We take it down to the denominator and make it positive. In number 14, we have a factor of k, and we have a power raised to a power, so we multiply like the rule says to do, and we get a positive 8.